Hi, this is Mrs. Robertson, and today we're going to do Chapter 5, Lesson 8, Factor Linear Equations. But before we do that, for those of you that weren't able to come to class, here are the answers to page 399. You didn't have to do all of them on this page. It was mainly the left side. Here are the answers for 1 to 7. You can pause if you need to do this. If you don't know how to get the answers, you can email me and I will try to help you by calling you or emailing you a response. And here are 8, 9. You didn't have to do 10 and 11, but if you wanted to do them, you can. All right. Now, the next page that you had to do for homework was 407. Feel free to pause at any time. If it takes longer for you to grade your paper, once again, this is page 407. And here's the bottom part of page 407. Okay, so for today, we're going to do part of the inquiry lab. This one's located on page 411. And it says, how do models help you factor linear expressions? Okay, factoring. We're going to be taking parts out and renaming our expressions, and that's what this lesson is going to be about today. Max has enough 1-inch square glass tiles to create a rectangular piece of mosaic art that has an area of 24 square inches. Some of the possible dimensions of the rectangle are listed in the table. Write the two missing possible dimensions. Okay, 24 times 1 equals 24. 3 times 8 equals 24. Who can give me another product that equals 24? Yes, Beckett.
6 and 4.
6 times 4. And another one, Oliver.
12 times 2.
12 times 2. Now you could have 2 times 12. It doesn't matter the order. Okay, those all give us a 24. Now we're going to look at the hands-on activity. Use algebra tiles to factor 2x plus 6. Well, they have 2 of the x bars and 6 of the singles. Okay? It says arrange the tiles into a rectangle with equal rows and columns. Okay, they did that there. The total area of the tiles represents the product. Its length and width represent the factors. Now, the rectangle has a width of 2 tiles and a length of 1 x tile and 3 1 tiles. So, they have 2x plus 6 equals 2 times x plus what? What's going to go in that box? Not 6. 2 times x is 2x. 2 times what is 6? 3. This is the distributive property here, kids. Okay, do you see that? Make sure you have a 3 in there. Now let's turn the page to 412. I have a couple zombies. They're frozen and not moving in class. Make sure you wrote down a 3, and we're now going to page 412. Nathan.
We didn't even check no work.
I'm going to collect it in a little bit and take it for a grade. Use algebra tiles to factor 2x minus 8, which is the same thing as add a negative 8. 2 x's, 8 negative red 1 squares, right? So now arrange the tiles into a rectangle. 2 by x minus 4. The rectangle has a width of 2 1 tiles and a length of 1 x tile and 4 negative 1 tiles. So we're going to rename this another way. We're going to factor out something. Okay, now they are subtracting, so I'm going to put a subtraction sign there. I'm pulling the 2 out because the 2 is a factor of 2 and 2 is a factor of 8, isn't it? So I need this stuff in here to equal this. So 2 times what will give me a 2x? X. And 2 times what will give me a minus 8? 4. So let's double check this. 2 times x is 2x, minus 2 times 4 is 8. All right, any questions on that? Okay, we're not going to take time for you to draw the pictures on this one. Let's go to page 413. Here it's all about drawing pictures. I don't want us to spend time right now. If you want to draw pictures later, you can. We're going to go on now to the back page, analyze and reflect. 2x plus 8 in a factored expression is 2 times x plus 4. The distributive property states 2 times x plus 2 times 4 equals 2x plus 8. Do you see what they're doing there? Put a little happy face. Now, 4x minus 8. That equals 4 times x minus what? 2. That's right. 4 times x is 4x. 4 times minus 2 is minus 8. That's the distributive property. Here we have 6x plus 2 equals 2 times, what's going to go in that box? 3x plus 1. So 2 times 3x plus 2 times 1 equals 6x plus 2. Do you see how we're getting this? All right. In this one, our common factor between a 2 and a 10 is 2. 2 times what is 2x? X. And 2 times what is minus 10? Minus 5. So you end up with 2x minus 2 times 5, and that equals 2x minus 10. Number 12. We're going to pull out a 2. 2 times 4x plus 3. So that will be 2 times 4x plus 2 times 3, and that will equal 8x plus 6. Any questions? And this is the distributive property. All right, now we are going to go into the actual lesson. Chapter 5, lesson 8. It's the last lesson for this chapter. Test is going to be Tuesday. We have a quiz tomorrow. Let's make sure we're all ready to go for this. Okay, page 415. I think we're just going to skip the real world link today since we went ahead. We did the inquiry lab. So I want you to go to page 416. Connor, question? Yes, take the pass. All right, monomials. Have you ever heard of the word monomials before? Okay, some of you have, most of you haven't. A monomial is a number, a variable, or a product of a number and one or more variables. Okay, these are monomials. That's a monomial, that's one, and this is one. These are not. X plus 4, 40x plus 120, okay? To factor a number means to write it as a product of its factors. A monomial can be factored using the same method you would use to factor a number. The greatest common factor of two monomials is the greatest monomial that is a factor of both. All right, so we're going to be factoring monomials today. Find the greatest common factor of each pair of monomials. Okay, kids, you break it down. 4x equals 2 times 2 times x. What are we doing? The prime factorization. Now, what's the prime factorization of 12? Well, remember how you could do the 12 like this? 2 times 6, and you circle the prime numbers. So the prime factorization for 12 is 2 times 2 times 3. And there happens to be an x. Nathan, are you seeing how this works? Now, to find the greatest common factor, you circle the things that they both have alike. They both have a 2. Go ahead and circle it again. They both have another 2. And they both have an x. So you make their pairs. So what's the greatest common factor of this? It's going to be 2 times 2 times x, which equals 4x. All right? Now, you kids are probably smart enough that you could look at this, and then you look at this is what I do. I look at my number. What's the greatest common factor of 4 and 12? 4. And they both have an x, so it's 4x. Okay? Now let's look at number 2. In number 2, we're going to do the greatest common factor of 18a. How do you get 8? What's 18's factors? Prime factorization, 2 times 9, and 9 will be 3 times 3. Okay, so that's how they get 2 times 3 times 3, and there's one a, so they write down an a. See that? Now we're going to do it for 20. What's the prime factorization for 20? Well, 2 times 10 and 2 times 5. Notice how I end up with all prime numbers in my circle. So for 20, you write down 2 times 2 times 5 times a times b. You got that? This isn't hard. Now you circle your pairs. They both have 1, 2. Now we can't circle that 2 because that one doesn't have another one. And they both have an a. See that? So what's the greatest common factor of that? 2a. 2a will go into 18a, and 2a will go into 20ab. Any questions? Okay, let's look at number 3. Here you have 12 CD and 36 CD. Well, 12 equals 2 times 2 times 3 times C times D. 36 equals 2 times 2 times 3 times 3. 4 times 9 is 36. Times C times D. Now we circle everything that they have alike. They both have a 2. They both have another 2. They both have a 3, which is 12. And kids, some of you would already know. It's like, I know 12 divides 12 and 12 divides 36. That works. They both have one C. Oh, and they both have a D. So your prime factorization is 2 times 2 is 4, times 3 is 12, times C times D. And that is it. 12 times C times D. Any questions? Okay, I would like for you to do A, B, and C right now. Okay, I've broken these down into prime factorizations, and now I'm going to circle what they both have alike so we can determine what our greatest common factor is. For 12, I have 2 times 2 times 3. For 28C, I have 2 times 2 times 7 times C. Well, they both have a 2 times 2, so the greatest common factor for letter A is 4. In letter B, they both have a 5, and they both have an x. So it's 5x. In letter B, it's 5x. Does there a 5x there? Yeah. And you'd get, there would be a 5x in that one. In this one, they both have a 2, and they both have a 7, and an M, and an N. 2 times 7 is 14 times M times N. 14 M N. Any questions on that, kids? Okay, now let's go to our next example on page 417. Yes.
So if this one is tested, do we have to do the work right here?
If it says show work, yes. All right. Because if it says show work, I give you points for the work. Sometimes they won't, you know, if it gets, and the more you practice this, the more I count on you being able to do things. But since we're still sort of rookies and this is your first experience, I want to see your steps. That way, if you get them wrong, I can fix you. If I can't see what you're doing wrong, I can't see into your brain. So that's why. Factoring linear expressions. Okay, let's look at this level here. You can use the distributive property and work backward strategy to express a linear expression as a product of its factors. A linear expression is in factored form when it is expressed as the product of its factors. Okay. Here, what you do is you look at this and you look at this. Oh, what's my factor? Is there a number that will divide an 8 and a 4? Yes, it's 4. And 4, they just did this step here. I don't think this step is necessary. I would just say, yeah, 4 will. 4 times what is 8x? 2x. Plus 4 times what is 4y? Y. Then you go back and you double check. Does this make sense? 8x plus 4y, yes. So you always go back on a test or a quiz to make sure your answer makes sense. Here they've done the problems with models. We practiced the models earlier, so you ended up with 3 and x plus 3. We did that earlier, so I'm not going to spend time with the models. We did that with the when we were doing the inquiry lab. Let's go on now down to D, E, and F. I want you to factor these problems out and then put your answers on the line. So, and sometimes they might not have a factor, so you just need to let me know if there are no factors. Example 5, I should have gone over that one. This one does not have it doesn't have a greatest common factor. It says there are no common factors, so 12x and 7y cannot be factored. When there are no common factors, that's an answer to a problem on your test. So make sure they ask you to find the factors, and if there's one that you can't factor, and it says explain why, all you have to say is there are no common factors. Yeah.
How do you do it with the subtraction sign?
You get rid of your subtraction sign. That would be one way. Yeah. Okay. I'm going to pause it. All right, so for D, that's what you would have. In E, what's our common factor between a 3 and a 33? Why, it's a 3. 3 times x plus, what am I going to put in front of the y? 11y. It's not that hard now, is it? No, you can do this, but you have to be careful. Are there any common factors between a 4 and a 35?
No.
No. So the answer is no common factors. So you can't factor it. You can't factor it if there are no common factors. Any questions? All right, there will be a question on the test where you'll have to explain why you can't factor it, because there are no common factors. Okay, page 418. Let's go to that page. We're going to go to the word problems. The drawing of a garden at the right has a total area of 15x plus 18 square feet. So that's a 15x and that's an 18. Find possible dimensions of the garden. Okay, so what are some possible dimensions? You factor 15x plus 18. What will divide a 15 and an 18? A 3. So then you have 3 times 5x plus 6. Do you see how they got that? This equals 3 times 5x plus 6. So the possible dimensions are 3 feet by 5x plus 6. All right, so 3 by is sort of like another word for multiply. A 3 by 5x plus 6. So it's a 3 by, so it's 3 feet on one side and 5x plus 6 feet on the other. That's probably doesn't make a lot of sense to you, but that's what that means. It says 3 feet by 5 by 6. You could say this is 3 feet and this is a 5 by 6 feet. Okay, let's go on now and look at our guided practice. Who can tell me what's your greatest common factor for problem number 1? Yes. Okay, it's not 4x, 4. 4 divides 32x, and 4 will divide an 8. Ooh, will 4 divide 18? Nope, it won't be a 4. Well, let's do our factoring. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, one more 2. Times 2 times x, and 18 is 2 times 3 times 3. Oh, the only thing they have in common is what? A 2. So your greatest common factor for that one is 2. I thought it was going to be 4 at first too. I see the 32. Yes?
I thought you multiplied the 2 that you got.
No, this is just 1, 2. You count your pairs. You multiply your pairs. So I have a pair of 2s. Now if I had another pair of something, it would be that pair times that pair. Okay, good question. Another question in the back. Yes?
So if you think about it, it's kind of like 2 over 2.
Yeah, it's your pair. Okay, for this one, I know that my prime factorization for this is 3 times 9, which is 3 times 3 times 3 times s. For 54, it's 3 times 3 times 3 times 2 times s times t. Now, sometimes s's look like 5, so be very careful. When you make your s's, I put little extra swirls on them so it doesn't look like a 5. Now, what are my pairs? I have a 3, I have another 3, I have another 3, and I have an s. 3 times 3 is 9, times 3 is 27, times s. So it's going to be 27s. Any questions on that? Okay, on the next one. 18. It's 2 times 3 times 3 times c times d. For 30, 2 times 3 times 5 times c times d. 2, 3, c, and a d. 2 times 3 is 6 times c times d. So 6cd. Any questions on that? Now, on the test or quiz, if you show this and you circle everything, but let's say you got off a little bit, I will give you partial credit for showing your work. Any questions? Connor,
How do you get 6? Because I thought it would be like 3.
what's 2 times 3?
Oh, you multiply that one.
Yeah, you multiply your circles. I have a 2 times 3 times c times d.
Where'd you get the 5 from?
The 5,
What is the
2 times 3 is 6 times 5 is 30. I was breaking down 30 into the prime factorization. Question? Yeah.
I was going to ask, like, how you got your numbers, like,
Well, you can do the factor trees. The factor tree may, and then after you do the factor trees, you realize you can do them in your head. 18, 2 times 9, and you circle your prime number. 9 is not prime because it's 3 times 3. So that's how I got 2 times 3 times 3. And then for 30, the factor tree, 3 times 10, and then 2 times 5. And then whenever I list them, I put them in order from little to big. You don't have to, but it just makes it easier to find your pairs, your matches. Okay? All right. Now, these are a little easier, and you can sort of look at some of, well, maybe not. Does anyone know what your greatest common factor is between a 36 and a 24? No, it's bigger than an 8. 12. Yeah. And we'll break it down. 2 times, let's see, 36 is 9 times 4. Yeah. 2 times 2 times 3 times 3 times x. And 24 is 2 times 2 times 2 times 3. And then what are my matches? 2, a 2, and a 3. So 2 times 2 is 4, times 3 is 12. And that's your greatest common factor. Not an x, because only one of them has an x. Does this one have any common factors? No. Question. Yep, so I had to show my factoring. So you did have to show your factoring on this. That's the factoring. Okay, and no common factors. Here, 2 times 7 times x, and then this is 2 times 2 times 2 times 2 times y. Now, here you can keep the subtraction sign on this in problem number 6. What do they both have? They both have a 2. So it's going to be 2 times 7x minus 8y. Or you could have 2 times 7x plus a negative 8y. All right? Now let's go to question 7. Mr. Finn's monthly income can be represented by the expression 25x plus 120, where x is the number of hours worked. There's a question on your test that's really easy, and it's set up like this, and it says what represents the number of hours worked. All you have to say is an x. It's a really easy question, but it's so easy some of you will find it hard on the test. Now, factor this expression. Well, what will divide a 25 and 120? 5. So you will get 5 times 5x plus 5 times, 24? Is 24 120? 0 carry a 2? Yeah, it is. Okay, and that's your answer for that problem. Any questions? Yeah, Connor.
For number 6, how did you get minus 8y?
Because there's a subtraction sign here, I needed to take 2 times this, and I have to end up with 14x minus 16y. Yeah, it was the subtraction sign in there, okay? All right, now let's go to what I want you to do for homework. I want you to do page 419. All, and then let's turn to page 420. I don't think I want you to do any of the problems on page 420. And on this page here, we're not going to do any of the problems on the bottom. I think all I want you to do is page 419. So what do I want you to do? Page 419 all, and then I think we need to practice our subtracting linear equations. So I then want you to go back, and on page 409, I would like for you to do page let's see, do I have 409 as your bell work tomorrow? No. Do page 409. Subtracting, and just do problems. Do 16 to 22. I'm not going to make you do the fraction ones. 16 to 22 on page 409. So you have 10 problems on 419, and on 409, 7 problems on page 409. So that's 17 problems, and you have about 15 minutes, maybe a little less than 15 minutes. Okay, there you go. Have a good day.